Just some other pictures to show other aspects of groundwater. Sometimes a rock might not be porous, but it's permeable just because it has fractures, cracks. There are rocks that have that characteristic, like limestone, for example. And so if you have water filling some of the void spaces in there, so you have your mini water tables depending on where the cracks are. And wherever you have a water table crossing the surface, that water will come out as springs. Here's another example here. You have your shale rock here. Shale is impermeable. That is, it doesn't allow water to go through. And above here, you have sandstone, which is permeable. And so water has infiltrated all the way into the shale and built up here to form this water table. And where this water table crosses the Earth's surface, the water will seep out, and that is what we call springs. Same kind of thing here. This diagram also explains something else. So you have few new terms here, gaining streams and losing streams. If you look at this stream flowing out of the page, okay, look at its water table all the way here, really high. Some of that water flows into the stream all the way along the entire length of the stream where the water table is high. Some of it will flow and add to the stream water. A lot of the stream water is coming from springs all the way upstream, or other small streams that run into it, and then it will run into a bigger stream and that kind of thing. But the point here is that groundwater also feeds streams. This continues to happen until the water table drops, as in the case of this second diagram. Oh, let me just go back here for one quick second and say this situation where a stream is receiving water, receiving groundwater, is known as a gaining stream. So it's gaining water from the ground as it flows in this direction. Then coming back to diagram B, where you have a losing stream. In this case, the water table has dropped significantly to the point where the water is no longer flowing to the stream. It is the stream water flowing into the ground and feeding groundwater. This case we call a losing stream. And when it becomes really bad, to the point where the water table is really below the stream, then you see that most of the water is just flowing down, seeping down straight into groundwater, and that stream reduces to a trickle. So you start out at the top with a strong flow, and then medium flow, and here it's down to a trickle because of what is happening with groundwater. In this diagram, you'll see some of the things that we've already talked about. You have your water table here, the blue line, or the line between the blue area and the gray. Of course, you see rain, so precipitation, that is what is feeding the groundwater. And where you have the surface intersecting the water table, water will flow out, and that is what is called a spring. Now, if you were to drill a well here, of course, you have water. You drill a well here, you have water. And of course, this is your river flowing out of the page. During the dry season or a drought, this water table could drop significantly. And when it does, as you can see, this well becomes a dry well. This spring becomes a dry spring. That's why sometimes you go through some regions that have springs, you go there another season and there's no water. That's because the water table has dropped significantly and there's no longer water there to feed the spring. The other thing to note here is that it's not every time that you drill a deep well that you're going to have water. This well is definitely deeper than this one. But the lower well, which is shallower, at this point still has water because of the nature of the water table. So you may have a neighbor, if you have a spring, you may have a neighbor who has water even during the dry season, and you don't have water, and maybe your well is even deeper. So it all depends on the groundwater, the slope of the water table. Okay? In this diagram, there is nothing very new here except just to let you see some other nuances. So you can have a situation where most of the rock is permeable, but you have what they call a shale lens, a lens of impermeable rock, which then helps to trap water above it and create a water table. And if you drill a well here, you have water. You could do that, and then you have a neighbor just up here who drill a well and no water because he or she was not able to get part of the lens. Or another neighbor here who will have to drill so much deeper in order to reach water, and another one here who will drill only a little bit and get water. So again, it all depends on the subsurface. The best way to drill a well is to first study what the water table looks like, and there are ways to determine the water table before you drill a well. Here are some other things to consider when you're looking at wells. So in this first diagram, you have your water table here, of course, and you have 3 wells. Okay, the one in the middle here is really deep, and they're pulling on it, and everybody is pumping their well, and the water table will start dropping. These guys, at some point, they will lose their water, whereas the guy with the deep well will continue to have water. But the terminology I would like to introduce you to is this one, cone of depression. So the water table doesn't always just go down perfectly horizontally. The region just around the well is depressed first. And that area of depression around the well, where the water table is depressed, is what is known as cone of depression. Okay, just another term to know. We'll talk about it some more later. In this diagram, you have something else. While in this upper diagram, the entire surface here is known as the area of recharge, where rain will fall and just go through. Here, the situation is different. You have this rock layer that has water. And here I will introduce a new term, and this is what is known as a confined aquifer. So an aquifer is a rock that contains water. So this is an aquifer. And this aquifer we say is confined because it is sandwiched between this layer that doesn't have water and this other layer that doesn't have water. And then, of course, the one at the top can hold water. This area, this rock layer that cannot hold water, and this one we call an aquiclude or aquitard. You'll see some of those terms later as well. So these are layers that cannot hold water. Now, how does this aquifer, this rock layer that has water, how does it get its water? Well, it doesn't come from the surface, because if it comes from the surface, when it gets here, it cannot go through. Its recharge area is all the way here. So along here is where you have your area of recharge. If you drill a well here, it represents a specific kind of well. They're called artesian well because the wells are under pressure. Why? Because if you measure the height from here to here, which is the bottom of the well, this column of water provides a lot of pressure. Water is quite heavy. In fact, you can test that by carrying a few buckets and try to run around your building. By the way, I hope you found that funny. In any case, if you have that kind of a large column of water, it has a lot of pressure here at the bottom. And so if you drill a well, the water from this well is going to shoot up all the way to the height of the water table. As you can see, this is the water table here. Okay, so water infiltrates here, gets all the way here, and then fills up all the way to the top. So the water table is here. When you drill this well, the water is going to jet out to the height of the water table. And so this is an example of a non-pumping well or an artesian well. If you drill a well, all you need to then do is cap it, and then when you open your tap, the water will flow under natural pressure from the water column. Whereas a well such as this one, you actually have to attach a pump to it and use energy to pump it out. So that's the difference between a non-pumping and a pumping well. Okay, so I am going to pause this video and do a second one just so that it's not too long. And when we come back, we'll talk about aquifers and aquiters, which I mentioned earlier. All right, see you shortly in the next video.